Hello everyone, my name is Oscar. I'm going to talk to you today about the Mopro. So the TLDR is kind of takeaway from this talk. There are three things I want you to take away. So the first is that we want to make proofs on mobile. Second is that Mopro is a toolkit for CK application development on mobile. And finally, let's make CK serial proofs on mobile great together. So we want to make proofs on mobile. Why do we want client-side proving? So let's put CK serial knowledge back into CK. I think over the last few years in the CK space, we have seen a lot of focus on sort of the succinctness properties you get from CK, and that's great and definitely needed. But if you want to get sort of privacy properties or interoperability and so on, you basically need client-side proving. So I'll give you some examples of this. So the first thing is SUPAS, Susalu. So Susalu is this kind of proto network state that happened. The first event was Montenegro last year. And basically you have this kind of CK identity system called SUPAS that allowed you to get entry into various events or do kind of voting and these types of things. And then later on, late last year at DevConnect, they also sort of, they improved on this concept or like added like games to it. So they did this thing where you have to catch cryptographic frogs. It's like ECDSA signatures, and if you caught like 50, you got like a green hat or whatever. And this is kind of maybe a silly example, but it's like people doing experiments in kind of a crypto fashion in terms of CK identity and private voting and these types of things. For more real-world examples, so there's a system called Aadhaar, which is basically a digital identity system in India. And it's huge. It's basically a necessity if you live in India. Like I think they have more than 800 million users. And whenever you sort of apply for a bank account or a job or getting an apartment or a loan or whatever, you basically have to give over your digital identity to the provider. And it's basically in the form of a PDF, and then there's this sort of RSA signature signed by the government in it. And it's great and very useful and so on, but obviously as you do that, there's some problems because you give up your information and all these types of things. So there's a product called Aadhaar, a PC-sponsored product, which basically adds CK to this. So you get things like selective disclosure. So you can imagine that you can prove that you have a valid identity or prove that you live in a certain province or what have you, without revealing, for example, your address or other personal information. That's pretty useful. And there's also other similar products like this, like Proof of Passport, which is kind of a similar thing in Europe for passports, and Mina in Japan, and so on. So there's a lot of these type of products, and I guess the general theme that we see in the last year and a bit before is that you have this kind of Web 2 digital identity system where you have cryptographic material, like if it's RSA signatures in the PDF signed by the government, or maybe GitHub public keys or Ethereum keys or what have you, and then basically taking that and permissionlessly adding CK and building systems on top of it. So that's a very promising direction that we're starting to see. And obviously this is a lot more complex than a SUPAS example in terms of the constraints that you have to prove and so on with RSA signatures. Other examples outside of CK identity, so going back to the origins of this space with Bitcoin and so on, like transactions and to make fungible money, so kind of private transactions, kind of like cash. Like if you don't want to have a record that sort of ties your salary to if you buy a coffee, then that's basically a necessity, and we still haven't seen sort of widespread adoption of that yet, even though there are products like Zcash and so on that are pushing for this. So to do that, basically, you need client-side proving, right? Because it's sort of how you would get those privacy properties, that sort of regain those privacy properties that naturally you get with something like cash. And I guess more generally, sort of private finances, if you get a mortgage or whatever, you also need some kind of client-side proving for that. There's also more novel examples, so sort of social networks, where you might want to hide the social graph. CK is very useful for that in terms of client-side proving. And then there's also other things like CKML. So recently there was a project at Oxford, I think, that used Mopro for this, where they basically take your private photos and they're able to prove something and do something cool about that. And that's another example of where you want to use sort of client-side proving. So I guess more generally, like what kind of properties do we want from client-side proving? So obviously it has to be secure and sort of trust minimized, so the user generates the proof and the key material is safe and so on. It should be fast, so you want to have good performance when it comes to big circuits in order for it to be sort of a comparable user experience to kind of similar systems. And this becomes a problem when it comes to things like Aadhaar because it's a lot more complex than just SUPAS or Semaphore or something like that. Another thing is that you have these bigger circuits, if it's RSA signatures in the case of Aadhaar, or some ECDSA keys, or GitHub, whatever, public keys or like email signatures or whatever, you get like a much larger anonymity set because there's already millions or sometimes even billions of these keys around. So if you can hook into that, it's much better for privacy purposes as well. And finally, it should be sort of friendly, so both to the user and developer, it should be very easy to use and robust and just kind of work. And I guess with something like SuperPass, it basically has to work on a phone, right? Because if you had a conference like this, you might not carry your laptop around, so it has to work fine, good on a phone, and it also has to work for like 95% of people, which means 95% of devices, because otherwise you can't really use it for gatekeeping events or voting and stuff like that. Nope. So, and when I say kind of client-side proving, I don't just mean browsers, I also mean sort of native proving. And you might sort of ask, like, why bother? And I think there are a few reasons for this. So the first thing is in terms of security. So if you do things natively, you get operating system level security with secure enclave and biometric authentication and so on. And that's important, for example, if you're talking about real-world identities, if you have your passport, you might not want to upload that to a random web view for security reasons. Also, performance is very important, as I mentioned before. So with native, you get native performance. So that's things like multi-threading and GPU hardware acceleration and these types of things. And while you can get that to some extent in a browser, it's always going to be not as good as native, and it's also going to be sort of less consistent across different devices and the browsers and so on. And finally, you get sort of better affordances, so integration with the phone, so whether it's camera or sensors, NFC, push notifications, secure enclave, persistence, and all these types of things. So you're just going to get a much smoother experience if it's native. Obviously, some trade-offs, right? So if you don't need an app, it's easier not to have an app. And there might be certain censorship avenues as well, depending on the platform. But finally, I think the biggest reason is just that it's very complex to develop and distribute and so on. And this is where Mopro comes in. So Mopro is a toolkit for Zeek application development for mobile. It's basically a set of libraries and utilities with a bunch of design goals in mind. So one is modularity. So it's very easy to sort of add additional proof systems and target different platforms and so on. And our design is very developer friendly, so it will be very easy to get started and sort of hide a lot of the complexity of mobile app development for you. And performance, as mentioned before, that's a very important goal, especially for these kind of more complex circuits that you want to prove from a phone to get a good user experience. And then finally, multi-platform, so that it works sort of on Android and iOS and React Native and so on. And you can think a bit like Foundry for CK app development, if you're familiar with that. This is basically how the main interface point, as a command line interface, we've been working on a bit recently. And you basically choose the platforms that you want, and then you initialize your product. And then you prepare sort of the circuits, for example, circumcircuits, and create artifacts around that. And then you can build on iOS and other platforms. And you can also do things like testing and exporting bindings and so on. So the idea is that you can get started as a developer in just 5 minutes and a few commands. And this generally is this sort of product structure. So you have sort of the core, Rust, scaffolding and so on your circuit. And then you have iOS product and Android, as well as a config. The config file just gives you a little bit more control in terms of the specific devices you're targeting on iOS and Android. If you want to have debug information, as well as sort of what circuit you want to use and where it is. But basically, we just bring your circuit and then just plug it into this config. And then after that, you get like an example application that allows you to prove and verify straight from mobile. And this is Xcode, so it just generates this product for you. So the resolution is not great here, but how does this work? Like I think you can think of it a bit like as these different layers. So you start off with the user, and then they're using some application, and then there's a bunch of tooling, and then it goes to like sort of the proof system and computer science at some point. And the general goal here is sort of separation of concerns and modularity, as I mentioned before. So user, I don't know if you can see, but they have like no brain. They don't want to think about things. They don't want things to work. You have the app developer who has a swift brain and just focuses sort of on making an application and making a great user experience. And the CK brain sort of just wants to focus on circuits, and then sort of a Rusty brain wants to care about tooling and so on. And there's also things going on here, and you don't have to understand it in detail. But what I'll do is I'll basically take one thing at each layer to sort of give you an idea of roughly how this works and what it looks like. So we start off sort of with the circuit, and to start off we're using Circom, which is basically the most used DSL for client-side proving. It's been around for a long time, and just empirically it's what a lot of products that are using client-side proving are still using. And you basically take your circuit as you have it, and then you can run Mopro prepare, and it will sort of generate the artifacts that are needed for it. This is then plugged into Mopro core, which is kind of the Rust core library, with these multiple adapters, with Circom being one of them. It's straightforward to add more, and we're doing a hackathon a few months ago. We had a sort of POC for Kimchi, which is a Plonkish proof system, so it's very straightforward to add new proof systems. And with this, you get sort of an API for initializing library, improving and verifying and so on, and dealing with serialization. And for Circom, we're using Circom Compat to load the circuit, and then the witness generation is either native, it's kind of a work in progress, or via Wasmer. And the proving itself is done natively with ArcGraph 16, which is part of the sort of ArcWorks family of libraries. After that, we have sort of the Mopro FI, so that's kind of the how you deal with talking across language barriers. So function foreign interface. And it's basically like a bridge between Rust and other languages, if it's Swift and Kotlin and so on. And it's wrapping this Rust core API and sort of dealing with what's called lowering and lifting. So basically, when you're talking across language barriers, a big num in Rust is not the same as in Swift, so you need to deal with that conversion. And it's using UniFi to generate binaries for these different languages, and supports iOS and Android and React Native, although that's a bit separate right now. But all of those platforms are supported. So UniFi, that's basically Firefox's answer to the question, how do you build complex multi-platform applications? Because at some point, you want to target different platforms, and you have a complex sort of business logic or whatever, then it's nice to have that in one code base, for example, sort of in Rust. And then you sort of have these thin layers for language binaries to these different platforms, whether it's desktop, Android, iOS, and so on. And I think we're starting to see that slowly in the CK space as well, where if you want your application to work and sort of reach mass adoption, you want to be able to use it from different platforms. And Rust is a great sort of choice for having the business logic somewhere and then just having these thin binaries to other environments. Once you have that, you sort of have these native binaries in Swift and Kotlin and so on, and you can use it in the application. So this is Anonada version 1. It's sort of a showcase app that's going to come up soon, hopefully. And it's using Mopro under the hood and then with React Native. So, and then finally, you obviously have the user, and they just want things to work, right? Like if you're using something, you're trying to achieve some kind of goal, you don't really want to think about details or what CK stuff. You just want things to work, right? And I think it's really exciting and cool if we as a space and ecosystem can sort of create these user experiences that kind of hide this CK voodoo stuff under the hood and just create amazing user experiences. So, zooming out a bit again. So the general goal here, without thinking about understanding all the details, is that we want to make life for you as an application developer easy, right? Because there's a lot of concerns here, like there's this UX and there's application development and like Swift libraries and tooling and proving systems and circuits and whatnot. And like, it's hard for one person or like you need a lot of people for this, or at least many hats. And with Mopro, basically, we're trying to split this up so you only have to focus on your area of expertise. So if you are an application developer, you only have to focus on making a great application and user experience for your users. And basically, the main interface is just this Mopro command line interface, few commands, and that's sort of basically what you need. And you can get started with that in like a few minutes. And from an application developer's point of view, basically, you're hiding all of the Rust and CK stuff under the hood. You don't have to think about that, which is how it should be designed. So I mentioned modularity as an important design goal. So that applies in lots of ways. So one thing is in terms of platforms. So it's trivial to sort of add support for new platforms, like if you want to make some kind of app in Python or what have you. Adding proof systems is also very easy. So we've done a POC for Kimchi. There's also some people that are working on other types of proof systems as well. And I guess generally with this type of tooling, you sort of get a lot for free because the concerns you have when you use a new platform or a new proof system are basically the same. It's like FFI and serialization and linking and packaging and so on. So once you have that tooling, it's not that hard to add like another platform or another proof system. And this Rust core is also used as kind of a selling point in the CK space in general because it's sort of fast and secure and flexible and has lots of developers. And finally, it's also a public good, this library. So it's not tied to some specific product or business. Basically, whatever is useful to developers and people is what we want. So we're not sort of shoehorned into a specific ecosystem or way of solving things. And thanks PSC and SearchPark for the grant. So where are we now? So I showed earlier the Anadar version 1 showcase apps. We've been working with that and also with the Proof of Passport product and supporting them. What happened with Anadar is basically we did a POC earlier, well, late last year. And at that time, the number of constraints were around 160,000. And now it's up to 1.6 million, maybe a little bit less, but it's still like 1 million, a bit above. And as you're increasing the number of constraints, you're obviously going to run into new problems. So a big focus of the last few months has been in terms of understanding the limits of client-side performance, like what happens when you have these many constraints and can we actually do it and so on. As well as other types of performance things that we're working on, like native witness generation and loading of various artifacts and just making it better to sort of support a good user experience. And then also improving developer experience. I showed the command line interface, just making it very easy for people to get started. As an example, we had this hackathon project we didn't know about that just used Mopro because it was useful to them, and they didn't even ask any questions stuff, so that's good. So hoping to see more of that kind of thing. As well as API and React Native support and stuff like that. So just briefly show you sort of, when we looked into sort of the limits around client-side proving, basically the biggest bottleneck by far is memory usage, and that's kind of something we would have guessed, but it's nice to have empirical sort of proof of that. And basically, oh, it doesn't show the whole graph here, but this is number of constraints. So it goes, this is 1.6 million constraints basically. So what that means is that if you have a phone with 4 gigabytes of memory, because you need a little bit of buffer for system and other applications and so on, you can definitely do like 1.6 million constraints and probably a bit above, so like 2 million constraints, something like that. And this is like a showstopper in terms of hard bottlenecks. There are also other performance concerns that I'm not going to go into detail about in this talk. But that's cool. That basically means that a lot of these CK identity systems like Anadar, Proof of Passport, and so on, they are on the order of the magnitude of like 1 million constraints. And as long as you have a pretty modern phone from the last few years, like 4 gigabytes or so memory, it might take a while, but you should be able to sort of create a proof from there. So that's pretty nice. So that's basically Mopro. And sort of a call to action, so let's make CK or mobile great together. So in Taiwan, some people might know this is an organization called Jilingvi Gov0. And they have this motto, which is, ask not why nobody's doing this, you are the nobody. And there's lots of ways you can contribute to this. So obviously, first of all, if you want to make a CK application, you can use it and write CK apps in it. And it's very easy now with Mopro command line interface, and you can provide feedback. But it's also like a community product. So there's lots of things that we would like to see and have added. So we want to have support for sort of more platforms and more proof systems and various performance improvements and docs and API and stuff. So lots of things to work on. And there's also lots of grants in the space. So if you're interested in this, you can definitely get funding for it. So in terms of platforms, we have experimental React Native support that can be a bit better integrated to make it easier for people to get started. Web would also be interesting. It's a bit of a sidetrack, but it would be nice to have sort of one code base that allows you to target all of these platforms one go. Proof systems, we have heard interest from both people to work on Halo 2, as well as Noir, in terms of client-side proving, but there are also other more exotic kind of proving systems you can imagine seeing. So like Nova and following schemes, Vol in the head is another one, Binius, and there's all kind of things that are new proving systems that make a lot of sense for client-side proving, especially in sort of a limited resource environment like a mobile phone. Performance, also a lot of things to work on, making the native witness generation work better and sort of more smooth. GPU, so we have some people working on a grant right now actually to sort of take advantage of the GPU, powerful GPU that we have in our phone. Moven is over there, he's working on that. As well as other things in terms of the documentation and API and so on that you can work on. So contributors, there's a bunch of contributors, both sort of in terms of upstream products and main contributions and downstream. SearchPark PSC for the grant and support. Vivian has been helping a lot building out Mopro, she's back in the back there. Yanis and Florent, who have been working on Anadar and Proof of Passport respectively, who also been helpful in terms of creating like a feedback loop for this. Moven and Food Chain that are working on GPU proving. Phil and Remco from WorldCoin, who have been doing a lot of similar things with Rust when it comes to CK proving for mobile phones, as well as Ariman and VAC. And hopefully you, if this is something that you're interested in. So, recap, we want to make proofs on mobile. Mopro is a toolkit for CK app development, application development on mobile. And let's make zero-knowledge proofs on mobile great together. Future is CK, the future is mobile, the future is now. Thank you. Here's some links to Mopro and me. Any questions?
And now we have 5 minutes for the QA. Does anybody have questions for Oscar?
Can you go back to the memory graph? Do you know why this relationship is linear? I mean, it looks too straight.
So it's basically because of the number of constraints. And then when you load it in Awkworks, you basically have to keep all of that in mind, in memory. There might be ways around that, but I'm pretty sure that's fundamental, especially when you come to Graph 16 and Halo 2 and stuff like that, because of perpetual powers of tau and how that works. There are other kind of proof systems that don't necessarily have this limitation. But yeah, so I think it's just fundamental because of the constraints and you need that in the proving. But there might be better ways around it, but yeah.
Thank you.
Do we have more questions for Oscar?
Actually, just one add to that. So this is linear, but you can probably reduce the constants a bit. So I believe if you do this with JavaScript, it's like the memory usage is twice as much, and you can probably pull this down a bit if you sort of use better techniques and so on, optimization.
Thanks for the talk, Oscar. My question is around the proving keys, which is the first bit, right? I think that can be over a gigabyte in some cases, right? So how do you think about solving that? Is there a way like making that stuff faster, maybe caching or?
Yeah.
That,
So the proving key size is definitely an interesting problem, and it's not a bottleneck, but it's important to think about in terms of app distribution and so on. So one thing we've done is that because we're using Awkworks, we actually took the set key and we turned it in what's really called like an arc set key, and it's using point compression and stuff like that. So now it's half the size in Awkworks, but it's still pretty big. So like for another, it's like on the order of hundreds of megabytes. One thing that you can do is you can sort of download it after the fact and then sort of load it into memory and stuff like that. So that's one approach, and we have experimental support for that. So yeah, that's one way we're dealing with it. But at the same time, it's kind of fundamental to Graph 16. So at some point, it's going to be too much, and that's when you might want to look at the alternative techniques. But for now, it seems okay-ish. Yeah.
Do we have more questions? Thank you so much, Oscar.
Thank you.